Hello everyone. Today my third lecture on classical mechanics. The topic is configuration space. Configuration space. The configuration of the system of n particles moving freely in space may be represented by a position of single point in 3n-dimensional space called the configuration space. Suppose our system have large number of particles. So large number of coordinates are required to their configuration. But if we assume such system is like a single particle, then 3n-dimensional space is required to their configuration. For example, suppose a system have single particle, then it can move freely in 3 dimension, and it has 3 dimensional configuration space for their representation. Just like this is a x-axis, this is a y-axis, this is a z-axis, and this is a particle t, and their configuration is given by such 3 dimensional space. Now in case of system have two particles p and q, so their representation is done by 6 generalized coordinate x1, y1, z1 and x2, y2, z2 by 3 dimensional space. अगर आप 3 dimensional space कंसिडर करते हैं तो इन दोनों पार्टिकल के 3 डिग्रीज ऑफ फ्रीडम होंगे और 6 कोऑर्डिनेट रिक्वायर्ड होंगे फॉर देयर कॉन्फ़िगरेशन इन स्पेस. But if we assume these two particles of the system assumed to a single particle, then their configuration is given by 6 dimensional space: 1, 2, 3, 4, 5 and 6 dimensional space. So this system is equivalent to this system. So you can say two particle system can be configured in 6 dimensional space. Just like a system have two particle m1 and m2 and their center of mass c. So all representation of the system are described by the position, described by the center of mass. Position vector, velocity and acceleration of the system is the same value of the center of mass. In this way, two particle of system is described by 6 dimensional configuration space. Imagine a system of 3n mutually orthogonal coordinates in 3 dimensional space. The exact position of single point in the space 3n coordinates are needed. That is called configuration space. मतलब system have n particles, so 3n coordinates are required to their configuration. But if n particle system assumed to a single particle, so 3n dimensional space is required for their configuration. Such 3n-dimensional space is called configuration space. However, one single point can represent the entire configuration of n particle. मतलब ये single point is can represent कर सकता है एक n particle system को. The path of single point also represent the complete system. एक particle का path पूरे system को explain कर सकता है. Configuration space particularly useful for describing constraints on a problem. Problem में constraints को describe कर सकता है configuration space. For example, consider a rigid body. Rigid body composed large number of particles, large number of atoms, and each atom is described by 3 coordinates. Just like n particle system required 3n coordinates, but there is the some constants that particle displacement, particle separation cannot be changes. So due to the restriction, only 6 coordinates are needed. 3 for one particle, 3 for other particle. मतलब 3n coordinates are needed in free particle rigid body. But if the particle of the rigid body are fixed, so only 6 coordinates are needed. 3 for position of center of mass and 3 for orientation of the body. In this way, 3n coordinates are reduces to 6 coordinates. मतलब मैं ये कहना चाहता हूँ कि जो रिजिड बॉडी होती है उस रिजिड बॉडी में पार्टिकल के बीच में कोई डिस्प्लेसमेंट नहीं होता है. इस कारण से अगर रिजिड बॉडी में n पार्टिकल्स हैं तो उन n का आपको अलग अलग कोऑर्डिनेट कॉन्फ़िगरेशन स्पेस में ना बताकर एक पार्टिकल का लेकर के एक सेंटर ऑफ मास को कंसीडर करके और उसके 6 कोऑर्डिनेट से ही उसका पूरा कॉन्फ़िगरेशन बताया जा सकता है. इन दिस वे कॉन्फ़िगरेशन स्पेस describe minimum number of coordinates to their configuration. This is the complete description of configuration space.